Greetings to all of you. In today's session, we are going to discuss about intermediate chemistry, which will be helpful for the international floor like entrance or any competitive exams if you are preparing for. In the national level, JEE Advanced and JEE Mains for engineering stream for NITs and IITs entrance exams. In addition to this one, NEET chemistry will be there, which is for medical entrance in India level, and also Telangana and Andhra Pradesh MCET examination for engineering entrance exam. So if you are aspiring for any government jobs in that condition, there will be a separate segment called general science will be there. In that also, the chemistry, whatever we are discussing, is very much essential. Let's enter into our today's session. Name the following compound as per the IUPAC protocol. IUPAC stands for International Union for Pure and Applied Chemistry. Here is the compound which is having carboxylic acid on one terminal, carboxylic acid on another terminal, and even central carbon is having carboxylic acid. There are three sets of carboxylic acids in the given compound. How can we assign the name for this? We will see. Right. So simply, if you are having only one carboxylic acid, the general protocol will be alkanoic acid. Alkanoic acid will be there. But if we are having multiple carboxylic acid, they are assigned with the common names like this. If you are having two carboxylic acid in the given compound called malonic acid, and if you're having citric acid stands for what? Carboxylic acids are three in the given organic compound. So these are called common names. Then what is the protocol in order to assign the IUPAC nomenclature for the given organic compound? It is commonly known as citric acid, which is well-known compound known to everyone, right? So we will see how can we assign numbering for this one. Actually, in general terminology, whenever the given organic compound having highest priority group in the one side, the numbering will be started from that end only. And always carboxylic acid carbon will be taken into the consideration in the parent chain, right? So that is the general protocol we will follow. But in case of this typical compound with the tricarboxylic acid functional groups. In this case, carboxylic acid is specially taken as a tricarboxylic acid, and whatever else, remaining chain is there, that to be taken into the parent. That will be, so if you are excluding three carboxylic acids, and the leftover will be 1, 2, 3. Three carbon chain will be there. Being it is a symmetrical molecule, either of the side you can start numbering, because here from left side numbering will be started like this. If you are taking from right side also, without any change we will get the same, because it is the symmetrical compound. In both the sides, equal extent of functional groups, equal extent of availability will be there, right? So that let me assign 1, 2, 3 rather than 1, 2, 3, 4, 5. Being it is the tricarboxylic acid, all three carboxylic acid taken as a 1, 2, 3 tricarboxylic acid only, and these three carbons are excluded from the parent chain. And the parent chain is of 3 carbons length, so that here propane will be taken as the suffix over here. And on the second carbon you can find hydroxy, so that let me put 2 hydroxy and 3 carbons, so that propane. Where you can find a tricarboxylic acid, and first carbon you can find, second carbon there is a carboxylic acid, third carbon also accompanied by carboxylic acid. Hence, entire name will become 2 hydroxy propane 1, 2, 3 trihydroxyic acid. This is the way you can assign the name for the given organic compound, and simply we can say citric acid. Common name is taken as the citric acid. Here you can clearly notice this. This is the way answer can be given for compound as per the IUPAC protocol. For compound number 1, the correct name will be 2-hydroxy propane 1, 2, 3 tricarboxylic acid, right? Move on to question number 2. Question number 2 is collected from Cambridge Assessment International Education, right? Potassium reacts with chlorine to form potassium chloride. It is a simple reaction called ionic reaction. So reaction between the metal and non-metal gives rise to the salt. This is a simple example for the ionic compound potassium chloride, KCl. Write a chemical equation for this reaction. Okay, so in order to get the balanced chemical equation, first of all, let me put potassium plus chlorine gives rise to potassium chloride. It is the simple ionic compound. Potassium chloride is a salt and it is the part of ionic compound. In order to form the ionic compound, one of the element should lose the electrons. In either element should gain the electrons. Finally, salt will be formed. Potassium metal, chlorine is the gaseous non-metal, and potassium chloride will be generated over here. So this is the way the product formation is possible, but it is not perfectly balanced. If you see two chlorines got consumed, here product is having only one chlorine, and this is not perfectly balanced. Move on to balancing the equation. Put 2 as a coefficient in front of potassium and chlorine will be there, and we will get 2 moles of potassium chloride. Entire thing is perfectly balanced. 2 potassium, 2 chlorides, 2 potassium, 2 chlorines. This is the way we can see. So this is called balanced equation. Second one is called balanced equation. What they are asking for, write a chemical equation for potassium reaction with chlorine leads to give KCl, potassium chloride. So second one is the balanced equation. Move on to question number part B. So in the second question only, another one is there. Potassium chloride is an ionic compound. Just now we said it is the part of ionic compound, no? Potassium is the metal having tendency to electropositive and release the electrons, and chlorine is a electron gaining tendency, electronegative in nature, so that gains the negative charge. Potassium by loss of electrons will gain the positive sign over here. By the gain of electrons, chlorine will acquire negative charge. This is the way potassium chloride ionic compound will be formed. Potassium plus Cl minus is the right representation of their charges. They are asking for the complete diagram, show the electron arrangement, the ions present in. Give the charge on the both the ions. Potassium is acquiring positive and chlorine is acquiring negative. Being it is ionic compound, this is the way we can represent ions, right? So transfer of electrons called ionic bond. Question number 3, we are moving to. Question number 3 is collected from JEE Advanced 2021 question paper, August PDF with the solutions, right? So this is an organic chemistry question and it is a part of reagent chemistry. The major product formed in the following reaction. This is the compound with the triple bond, and here also any the triple bond. There is a difference. The triple bond whichever present here is the terminal, means one side, and this is the triple bond present is called a central, which is surrounded with the two sides alkyl chain, right? So terminal alkyne is there and another central alkyne is there, and this two set of alkyne, our triple bond is located. Now we are going to treat with sodamide in the presence of sodium metal and liquid ammonia. Sodium metal, liquid ammonia, when combined, formation of Na plus and NH2 minus, which is called NaNH2. This is called the Birch reducing agent, and it is selective for the reduction of the central alkyne or central triple bond rather than terminal. Terminal is the acidic hydrogen containing one which can't be reduced by means of this Birch reducing agent, sodium dissolved in the liquid ammonia. So only the reduction of this one is carried and not a complete reduction, rather that participate in the partial reduction. We will see what is the possible answer. And stereochemistry also matters over here. If you see the possible options, in the first option they mentioned all two triple bonds got reduced. In the second, terminal triple bond unaffected, but the central triple bond is reduced partially, means a triple bond converted into double bond, not single bond, no, so that we can say partial reduction. And here if you see, terminal triple bond remains as such, but here whatever triple bond is there became double bond. Can you find any difference in between B and C? Here is the double bond orientation is trans. Here double bond orientation is cis. Two alkyl on the same direction. Here two alkyls and up or down. So this is the trans geometry. This is the cis geometry. So that kind of difference you can notice in between B and C options. In third, in the last D option also they mentioned Both the alkynes got reduced, but terminal alkyne is having a double bond like this, and the central alkyne is having double bond with the cis orientation. Here, the compulsory condition for sodium in liquid ammonia, whenever triple bond is reduced, whatever double bond is generated must be trans rather than cis. That is proved over here. If you see this, this is collected from the Liber text. Internal alkyne if taken, internal means this triple bond is not on the terminal last carbon. Instead, it is in the central carbon. So here set of triple bond if present, treated with hydrogen in the presence of metallic sodium or else lithium. Either of the metal you can use, all are S block elements only, and dissolved in the liquid ammonia. Liquid ammonia used to facilitate the reaction under free radical mechanism. Electrons will be released, free electrons will be released in this, and electrons used to occupy on this triple bond, and the latter hydrogen will be attached, and this triple bond now turned into double bond. If you see, this double bond is having two hydrogens. If you notice two hydrogens, both are same side or opposite side. Both the hydrogens are oriented in a opposite direction, so that we can say it is the trans. Always the sodium liquid ammonia gives rise to the triple bond to double bond in the trans direction. This is the compulsory stereospecificity. This is the specific condition we can acquire by this. Another reagent will be their Lindblad catalyst, which is the combination of palladium barium sulfate, palladium metal. Barium sulfate is the kind of salt we can take. So that is having a reduction of terminal alkynes also, which is not possible by Birch reduction. And here central alkynes are present by means of Lindblad catalyst. Here the possibility of cis. Cis formation is the Lindblad, trans formation is the Birch reduction. This is the way we can differentiate, we can distinct both the reducing agents. Both are having the same activity, triple bond to double bond only, but triple bond to double bond formation trans with sodium liquid ammonia, cis with respect to Lindblad catalyst. That distinction we have to notice. Fine. So based on the entire data, whatever we observed as of now, sodium in liquid ammonia gives rise to the reduction of the central triple bond rather than the terminal triple bond. Terminal triple bond is unaffected. And this central triple bond obviously converted into trans double bond formation is possible. Both are fulfilled in the option number B. In the option number B, only one triple bond got reduced, and we got a double bond as a trans one, and terminal triple bond is not affected. The entire data is particularly suitable for the option number B. For question number 3, option number B will be the correct answer. And we entered into question number 4. This is from physical chemistry. For the given closed packed structure of the salt made up of cation X and anion Y shown below, ions of only one phase are shown. Only one phase is taken into the consideration. This phase is considered over here. Ions of only one phase are shown for the clarity. The packing fraction is approximately, we need to calculate the packing fraction. Packing fraction is equal to packing efficiency by 100. So this is the way we have to go for the calculation. So closed packed system is there. Cations are denoted with the X and anions mentioned with the Y. So one cation is surrounded with 4 anions like this. So for this, expected answer will be 0.63. How can we achieve this answer? We will see, right? In order to calculate the packing fraction for the closed packed system, there is a formula. The formula will be 3 into 4 by 3 pi r cube plus 1 into 4 by 3 pi r cube by a cube. This is the formula for packing efficiency for given closed packed system. If you see this, there is a kind of repetition. Pi r cube got repeated, 4 by 3 also repeated, so that we will go for what? take the common of the entire one, so that it will become 4 by 3 pi into 3 into r plus, here this term is given as r plus, no, r plus cube, and this entire one taken out. That's the reason why this 4 by 3 pi already there, no, so here you will get r cube only. Okay, by a cube will be there. So this is the where you are taking 4 by 3 pi r, not 4 by 3 pi taken as the common for both the terms. For both the sides you are taking 4 by 3 pi as the common thing. So if 4 by 3 taken out, what happens? 3 into r cube left here. Here only r cube, 1 into r cube will be present, by a cube will be there. What we are doing, numerator term and denominator term both you are dividing with r cube. Okay, so the topmost region, bottommost region, both are used to be divided with the r cube. When you are doing that, what happens? 1 into 4 by 3 pi, 3 into r plus, here r plus cube is there, no? So r plus by r whole to the power 3 you can mention for our simplification. Okay, here already r cube is there, divided with r cube. R cube divided with r cube both get compensated, so that plus the leftover term will be 1 only, right? So here in the denominator a cube is there. If you multiply, sorry, if you divide with r cube, so that let me put a by r whole to the power 3. This is the way we can simplify the equation. 4 by 3 pi, 3 into r plus by r whole to the power 3 plus 1 by a by r whole to the power 3. This is the way you can simplify the equation. Here some known terms will be there. 2r plus is given by a. So if 2r plus is given by a, you can put a by r is equal to 2. There is a value. A by r will become 2, right? And another ratio r plus by r, the value is known to you 0.414. So r plus by r value is also known, that is 0.414. Okay, if you are going to substitute these two known terms, we will get the final answer, packing fraction. Okay, here the equation will be 1 into 4 by 3 pi. Pi value will be 3.14. 22 by 7 can be simplified as 3.14, right? So here 3 remains as 3 only. And here r plus by r value is known. R plus by r value is 0.414. That can be taken 0.414. And here we have a cube. So let me put a cube over here. And the plus 1 is there. Plus 1 remains as such. A by r. A by r is given by 2, no? So that denominator will become 2 to the power 3. Okay, so after calculating the entire numericals, we will get the value as 0.634. 0.634 is equated as 0.63. 0.63 is the packing fraction of closed packing system. Okay, so this is the cube whose packing fraction is calculated as 0.63. That 0.63 is calculated by taking the formula 3 into 4 by 3 pi r cube plus 1 into 4 by 3 pi r cube by a to the power 3. This is the way we can solve the question. For question number 4, option number B will be the correct answer. Move on to question number 5. Question number 5 is collected from Telangana Gurukulam Degree College Lecturer Entrance Examination. And this is the question, we can say it is the part of volumetric analysis. The aqueous solution is isotonic in HCl, NaCl, K2SO4. The amount of ions H plus, Na plus, K plus, Cl minus, SO4 minus 2 in their ppm units are in the order of. Okay, these many aqueous solutions are given to you. Hydrochloric acid, sodium chloride, potassium sulfate, these many salts are given to you. In that, amount of individual ions to be calculated. And there is a hint, all the solutions are said to be isotonic in nature. Isotonic stands for if all the solutions are equally concentrated, those are called isotonic solution, right? So let's solve the problem. Isotonic solution stands for Osmolarity is same for them and they are having equal concentration. Okay, all the solutions are equally concentrated. Those are called isotonic solutions. For these isotonic solutions, individual ion amount to be calculated in ppm, parts per million, right? So for that purpose, the correct answer will be H plus less than Na plus, greater than Cl minus, less than K plus, less than SO4 minus 2. SO4 minus 2 is having highest amount, and the latter, this will be the order for the given question. Let's find how to solve this question. Right. So here is the clear description is given for isotonic solution. Any solution is made up of two components called solvent and solute. So solvent and solute particles present. Solute particle number matters for the concentration. If both the concentration, solution 1 concentration, solution 2 concentrations are exactly equal, concentrations are exactly equal, both are said to be isotonic in nature. This is the way we can give the definition for isotonic solution, right? Now we are going to get the solution part. Being all are isotonic, let me assume all are 1 molar solution. All the solutions are of 1 mole. Okay, so 1 molar concentrated solutions. For 1 molar HCl, we can have 1 molar H plus ions and 1 molar chloride ions will be there. Okay, this is for what? Concentration. If you want to calculate its amount, weight is nothing but amount of H plus is equal to, how can we do this? Molarity can be multiplied with its atomic weight. Molarity is taken as how many? 1 molar solution it will be, so that molarity is 1. Atomic weight of hydrogen is taken as 1 only, no? So that amount of H plus is taken as 1 multiplied with 1, that is 1 itself, right? Then amount of chloride, so molarity is 1. Chloride ion atomic weight, ionic weight will be 35. 35 multiplied with 1 will become 35 only, no? So that chloride amount will be 35. If you go with 1 molar sodium chloride, 1 molar sodium chloride contains 1 molar Na plus ions and Cl minus ions as well. In order to calculate amount of Na plus ions, 1 mole, so that 1 can be multiplied with atomic weight of sodium. Sodium atomic weight is 23, no? So that 1 multiplied with 23 is a 23. Amount of sodium is 23. In case of potassium sulfate, potassium moles are 1 by 2 K plus, and SO4 minus 2 moles are 1 molar, because 2 potassium combines with 1 sulfate. 1 potassium will become half mole. 2 potassium will become 1 mole, right? So in case of 2 potassium, it will become half into 39. Half into 39 will be 19.5. So that is for only 1 potassium. If you want to get 2 potassium, 19.5 can be multiplied with 2. So that 39. Okay, potassium amount will be 39. Amount of sulfate. Sulfate amount will be, molarity is again 1. Sulfur atomic weight is 32. Oxygen is 16. Can be multiplied with 4 times. So that sulfate ionic weight is calculated as 96. Sulfur will be 32. Oxygen will be 16. Can be taken 4 times. 16 taken 4 times. So that 96 is the formula weight for SO4 minus 2. 96 highest for sulfate, so that the right order will be, obviously lighter will be H plus, whose atomic weight is amount is given as 1 only. Sodium amount is given as 23. So next sodium will come, and the potassium, Cl minus, chloride will be there. That chloride will be 35, no? That's the reason why 35 will be taken. And the potassium will be 39. Potassium is 39. Highest will be sulfate, that is 96. 96. So if you are taking right order, sulfate will be highest, next will be potassium. This is the right order for the calculation of amount of ions present in this isotonic solutions. So in order to solve this one, we have to know the terminology involved in the chemistry. What is meant by isotonic solution? What is isobaric solution? What is isochoric solution? This kind of terminology matters in order to calculate this one. Though we know everything and how to calculate, but we have to know the terminology exactly, then only we will go in a right direction. For question number 5, option number 4 will be the correct answer. Move on to question number 6, last question of the session. This is also the part of what problematic section only, and we will say it is the kind of physical chemistry question. The formula weight of M2X3. M2X3 is the kind of salt can be taken. Its molecular formula weight is taken as 120. Formula weight of M2X3 is given as 120. Solubility in water is 25 degrees centigrade. Solubility of this salt is at 25 degrees centigrade is 60 gram per liter. 60 gram per liter is given. How much is its solubility product at this temperature? If solubility is known to you, obvious to calculate the solubility product of the solution also, right? So the correct answer will be 3.37, and we will see how to achieve this 3.37. In order to get that one, first of all, let's put the salt in water. Whenever this salt is added to water, M2H3 salt added to water, it will be dissociated into 2 moles of M plus 3 ion of aqueous solution and 3 moles of X minus 2 ion in the aqueous solution. This is the way ionization is carried. And in order to calculate solubility product is the sum of all the ions present in that. M plus 3, how many ions are there? 2 ions are there. So that let me put M plus 3 whole to the power 2. And X minus 2 ions, how many? 3 coefficient will be there. So that X minus 2 rising 3. This is the way solubility product. Solubility product is the product of solubilities of individual ions. Individual ions, cation is M plus 3 whole to the power 2. Anion is X to the power minus 2, X minus 2 whole to the power 3. So if you take the product of these two, KSP will be calculated. For that purpose, KSP, just now we mentioned KSP is equal to M to the power plus 3 whole to the power 2, X minus 2 whole to the power 3. X is given by 60 gram per 1 liter. X is calculated as 60 gram per 1 liter into 1 mole by 120. This is the way we can go for the calculation. 60 is the solubility of individual salt, no? That 60 gram per liter, they said. So that 60 by 1 liter into 1 mole. The 120 is the molecular weight, formula weight of M2X3 salt. Okay. So after calculating 60 by 120, it will become what is 0.5. X value we calculated 0.5. So in case of this solution, KSP is required to be calculated and KSP formula is given over here. And in order to calculate the KSP, here 2x whole to the power 2 into 3x whole to the power 3. This 2x belongs to what? M plus 3. Entire terms will be converted into this x terminology. M plus 3 is becoming 2x whole to the power 2. And this negative charge is indicated as 3x whole to the power 3. Okay. So x value is known to you. X is taken as 0.5, no? 2 into 0.5 whole to the power 2 and 3 into 0.5 whole to the power 3. If you substitute like that, 2 into 0.5 whole to the power 2, 3 into 0.5 whole to the power 3. If you calculate like this, the KSP stands for what? Solubility product constant is calculated as 3.37. 3.37 is correct answer, which is given in the option number 1. Chemical equilibrium related question. It will be chemical equilibrium plays vital role in the intermediate chemistry, and it contains the highest weightage over there. For sixth question, option number 1 will be the correct answer. So hope this session will be helpful for your preparation. and entire thing will be helpful in achieving whatever goal you have, and the entire one is really understandable. So that I'm sincerely requesting you to like the channel and comment which part is really interesting over there, and share with us parents which are seriously preparing for the exams, either entrance or any competitive exam. Subscribe the channel in order to receive more such updates in the near future. Thank you very much for your patient listening. Thank you one and all.